Alright, so first we're going to look at the points -3, 4, and 6, -2. And we're going to do a number of things with them. We're going to find the distance between them, we're going to graph them, we're going to find the slope between these 2 points, or the slope of the line that these 2 points are included in. Find some equations relative to these points, and we'll find the midpoint between the 2 points. We'll find a perpendicular, and we'll find a parallel line. So first, let's plot these 2 points. We have -3, 4. That means if this is my x and this is my y, then the first of the ordered pair is going to give me my x. So I'm going to move back 3, -1, -2, -3, and then move up 4, 1, 2, 3, 4. And I have my first point. I'll go ahead and label that A. This would be my A point. And then for B, we move over to the right 6, 1, 2, 3, 4, 5, 6, and we're going down 2 because it's negative, and I'll call that B. Great. Okay, so now that we have those 2 points, one thing that we could ask is how far apart are they? And one thing that we can imagine here is that we have kind of a right triangle, and we want to figure out what the hypotenuse of that right triangle is. I'll go ahead. We want to find the hypotenuse of that right triangle. Now my drawing is going to be a little inaccurate here because of my graphs, but we'll get the idea. Okay, so if we remember from our Pythagorean theorem, we have a squared plus b squared equals c squared. That means the square of one leg plus the square of the other leg gives us the square of the hypotenuse. So in this case, to figure out how long this leg is, what I'll do is take the difference of the y values. So if I say little a is the length of this side, I'm going to take the difference of the y values, and that's going to tell me how far that is. So that's going to be, we'll say 6 minus, the y values. So we'll say -2 minus 4, and we can square that. And then here we need the difference of the x values to figure out how long that is. So we're going to have the x values, 6 minus -3, and square that, and that gives me my c squared. Okay, so here I have -6 squared, that's going to be 36. Here I have 6 minus a -3, so that's going to give me 9, and I square that, I'll get 81, c squared, and then, so that's going to give me 117, that's c squared. So c must be the square root of 117. So that's the distance. And if you think of the square root of 100 being 10 and the square root of 121 being 11, this is somewhere in between 10 and 11 units. And hopefully that seems reasonable. We said one side was 9 units long and one side was 6 units long. So to be, it has to be the longest side, so it's longer than 9, and it's shorter than the 2 pieces put together, so it's shorter than 15, so we're in good shape. So we'll go ahead and say that that is the square root of 117 units long. Okay, we can also use a similar approach to tell us what the slope is. Remember that the slope is the ratio between the difference of the vertical change and the horizontal change. So we'll go ahead and create that. We have our slope, which is the vertical change. That's this. So -2 minus 4. And then the horizontal change, 6 minus -3. So in the same way, we had -6, and we have have positive 9, so our slope becomes negative 2/3. That means for every 3 units we move to the right, we move down 2. And we can get a feel for that. Alright, so now we have the slope, and this slope actually gives us an equation as well. If I rewrote this as negative 2 minus 4 equals m times this here. Now, to make it general, I can replace one of these points. So this was a y value. And I can go ahead and put in my slope here, negative 2/3. And this was an x value. And so I'm going to simplify that a bit. And now I have an equation for this line that any point on here falls within this relationship. Just to be clear, that's a 2. So I've created, this is what we call the point slope form, because I use a point, negative 3, 4, that's our point A, and I use the slope. Now I can simplify this. I can distribute, and I'm going to move over my 4 here as well, so I'm adding 4, and I'm going to distribute, so I get negative 2/3 x, and then negative 2/3 times 3. The 3's, you'd have 3 over 3, so that's 1, so we get negative 2. And then when I combine my like terms, I get a positive 2. So I have y equals negative 2/3 x plus 2. And that's what we call the slope-intercept form. It's the slope-intercept form because we still have the slope, and then we can easily find the intercept. Remember, the y-intercept is where x is equal to 0. So if we put in a 0 here, negative 2/3 times 0 gives us 0 plus 2. So our y-intercept equals 2. So if I had drawn this to scale, we'd be on that dot there. All right. Now the x-intercept in the same way is where the y value is equal to 0. So if I put y is equal to 0 and I have negative 2/3 x plus 2, I can subtract 2 on both sides. And now I'm going to multiply it by the reciprocal on both sides. So I'm going to multiply both sides by negative 3/2, negative 3/2. And what that does is eliminates this by making it 1. So we have 1x, which is just x. And then our negatives cancel, our 2's cancel, and so we get 3. So we also have a point here at 3, 0. That's our x-intercept. Alright, so we've done slope and distance and equations. That gives us quite a ways. The next thing that we can talk about is the midpoint. So between A and B, what's the midpoint? Well, we can guess that it's probably somewhere in this range here. Okay. The midpoint formula is based on the notion that if you take the distance from the origin of each piece and then average that, you get that. So in the same way, we can take our x values, so in this case 6 and negative 3, we'll add those together and divide by 2. So that's positive 3, so we get 3/2. That's our x value. And then we take our y value and we get negative 2 plus 4 divided by 2. So that's 2 over 2, so that gives us 1. So we have a point at 3/2, 1. So a point at 3/2 is here and here. And again, those would all be on the line, but my graph is a little wonky. Okay. So that's our midpoint at 3/2, 1. Okay. Now, the next thing I might want to do is create, let's say, a perpendicular that runs through the origin. Well, the nice thing about perpendiculars is that once you have an equation with a slope, we can take the opposite reciprocal, and in this case we could use point slope form, or we could use slope intercept because we see that it intercepts at 0. So a perpendicular through the origin gives us y equals, and in this case our plus b is 0, so we just need the opposite reciprocal slope, which would be 3/2 x. So we have a perpendicular line running through the origin, like that. Okay. And also for a parallel line, we just want slope to be the same, so we could do that as well. I think that gives you a pretty good idea of a lot of different things you can do and how they're related in terms of graphing and finding distances and all of those different parts of a linear equation.